Your next challenge is called The Highest Profit Wins. Ben has a very simple idea to make some profit. He buys something and sells it again. Of course, this wouldn't give him any profit at all if he was simply to buy and sell it at the same price. Instead, he's going to buy it for the lowest possible price and sell it at the highest. Task: write a function that returns both the minimum and maximum number of the given list/array. We can see it's an array in our case, right? Examples: consider the array 1, 2, 3, 4, 5. You will output a size 2 array with 1 and 5. 1's the lowest, 5's the greatest. You put the lowest first, the highest second. You have a size 2 array here. Notice the 5 went first and this larger number went second. And then finally, in the event that you have just a single value, you would return that value for both the low and the high. All arrays or lists will always have at least one element, so you don't need to check the length. Also, your function will always get an array or a list. You don't have to check for null, undefined, or similar. Certainly, we've done enough of that where you could do that if you wanted to, right? You could say if, list equals null, or they didn't even call that, they called it LST, list.length is less than 1, right? You could throw an exception if you want. And you can pause and do this, but I think we've done enough of this where you know how to do some error checking. We don't have to assume that those conditions hold. You won't in the real world. You can do it here, but you won't in the real world. So go ahead and pause, and I know you can do this one if you've been following along in the series, and then come on back and we'll go through it together. So I'll do 2 solutions. I'll do a quick linker, one-line linker, and then we'll go over another solution because I don't like the LINQ solution the best here, at least not the one that I'm going to show. So if you've been, if you keep your C# enumerable, if you keep your doc page open there, you'll notice under methods, we've used these before. We've got max and min right here, right? And so they'll go through the enumerable collection and just return the element that is the maximum. So what you could do is say return new integer array, right? And we could say for the elements list dot, I think it was the min first, right? And list dot max. You can call that, and I think that will do it. Let's see. And yeah, so that's one way to do it. The reason I don't like this solution is that min is going to go through the whole array, right? Because it's just an array. It's not. We don't know if it's ordered or not. We have to assume it's not ordered. So it's got to go through every element in that array to determine which one's the minimum. And then it's got to do that same thing for maximum. So I'm thinking this is going through that list array 2 times. And so I want to make my own where I just go through the collection once. I don't want to do it 2 times. And it should tell us if we go to max or min. A lot of times they'll give you the efficiency of the algorithm. But it should be O of n. Do we have anything like that in here? Let me search for it. O of... No, maybe not. Okay. Well, it's got to go through all of the elements to do its job. So, yeah, you can use this if you want a one-liner. I'm going to remove it, and I only want to go through the collection once. I'm trying to be as efficient as I can be. So I'll make a loop for this purpose. For each int n in list, we've seen this for each loop, right? It's like a for loop, but you don't have the index value. And then what I'm going to do is I'm going to make my integer array, I'll call it result, equals a new int array size 2, and I'm going to initialize it with a couple of values. So my plan is going to be that I set up this array, this result array what I'm going to return as part of our method contract, right? And I'm going to give it initially the maximum integer value for the minimum and the minimum possible integer value for the maximum, with the idea being as I check elements, they get compared. So imagine, let's just look at minimum so I can make this clear. If we compare against, if we're trying to get the minimum and I do something like this, remember we've seen this before, max value just gives you the maximum possible value that could be stored in a 32-bit integer. If you go above it, you overflow, right? So with signed integers, we saw that was 2.147 billion or something like that. And so the min value, I think, is negative 2.147 billion with signed integers, meaning you can have positive and negative. And so if I just set it at max value, right, the first n I encounter in list is going to beat this, so to speak. It's going to be a lower value than max value. I mean, it could match, right, if the array contained in 32 max value. And that's fine too. That means it is the minimum value that's been encountered at the time. But the idea is that you get a meaningful setting once you encounter a value lower than that. But this is the worst possible value it could be, so to speak. So I'll say if n is less than result 0, right? Because we're putting that in the first slot. And just so this looks all right, let me put the other one. And you can imagine it's the same logic but reversed here, right? We start with the minimum value, and then any values we hit are probably going to be bigger than it, and then we set the largest value, and it keeps getting updated as we go through the loop. Same logic, just kind of inverted. So now that we have that, we could say if n is less than result 0, this is the slot that should hold the minimum. That means, hey, we have a new minimum. We found one. So we could say result 0 equals n, right? And then you imagine it's the same kind of thing if n is greater than result 1. Result 1 equals n, right? That means we found a new max, so store that. And what I like about this is that we just have one for each loop, right? We're going through the entire list, but we're only doing it once. And then finally at the end, you should be able to simply return result. And I'll go ahead and hit the attempt here. Good. So I'm going to submit mine like this because I like it better than the LINQ solution. The one here where I think it's going through the collection, I'm sorry, up here, where I think it's going through the collection 2 times, one to find the min and one to find the max. And I'm sort of pulling double duty here by watching for both as I'm going through the list, doing it once. So yeah, they're going to make me attempt again because I modified the code. I think I took all the fluff out. You could take the this bit out if you want. I'll leave it in. Maybe I'll get a best practice vote or something like that. Attempt. Remember, it's not a race to cram code. I could submit the one-liner, right? But I suspect that this is more performant. So yeah, it's longer. Maybe I don't look as fancy, but if I get better results, that's what matters, right? And you'd test on a run with a large input size to make that determination, and it can be different on different machines. So I'll submit, get those points. We're up to 918, looking good. Lots of honor. And so yeah, you get the last min. And I think I had put the integer array size in, but you notice you can omit it too because it can tell you're using the curly brace initializer to initialize your integer array. And so it can tell you've put 2 elements in there. It knows the integer array should be size 2. But as you saw, I had put the 2 in, and that's fine too if you want to be very explicit about it. And yeah, this is more like what we did. Like that one better. That's my taste. So yeah, feel free to look through these all you like. Otherwise, show me your solution. Hit me up with questions, comments, concerns. Otherwise, we'll keep rolling. Thanks for watching.